In this homeostasis module, I'm going to talk about insulin and glucose release. So here we're looking at the pancreas as an endocrine organ. So remember that the pancreas is both an endocrine organ and an exocrine organ. So as an exocrine organ, it's going to secrete contents out of the organ. As an endocrine organ, it's going to secrete contents in the form of hormones into the bloodstream. So when we're considering insulin and glucose release, we're looking at the pancreas as the key organ. You might recall that the pancreas has two functions. So it functions as an endocrine organ, where it secretes hormones into the bloodstream, and also as an exocrine organ, where it produces components for the processing of food. So those components are secreted outside the organ into the digestive system. Insulin and glucose release are regulated via a negative feedback loop, and so blood glucose levels are what's being measured in the feedback process, and raised blood glucose levels stimulate the release of insulin. Insulin's got quite a short half-life, so this is a constant process of regulation, and it requires reasonably tight control so that the body's functioning at optimal capacity. So insulin produced by the pancreas has a number of functions. It enables glucose to enter target cells, and in fact increased insulin levels actually improve the ability of glucose to enter target cells. Insulin also triggers enzymatic activity to enable glucose conversion to ATP, and you might recall that ATP is the energy molecule required for our cells. Glucose enhances glycogenesis. So this lowers blood glucose levels. So genesis, you'll recall, means new, and glyco, we're looking at glycogen, so we're looking at really that fat storage or the energy storage molecule. Insulin also stimulates amino acid uptake and protein synthesis, and so these are both important for functional capacity of the cell. Insulin helps to convert glucose to fat, so again, genesis meaning new, lipo related to fat. So excess glucose is actually stored as fat, which is worth remembering if you're thinking about losing weight and those kinds of things. So it is a fat storage molecule if you have excess glucose in the system. So you really need to think about looking at things that are low GI so that we maintain that stable balance of glucose in the blood and we don't get excess production of this hormone that's going to lead to excess fat storage. Insulin production inhibits glycogen breakdown into glucose. So glycogen, remember, is the energy storage molecule. So if you've got glucose, excess glucose, you're going to get insulin produced, and the message as far as the feedback loop is concerned is going to say we don't actually need any more energy, so don't be busting up this molecule so that we get more glucose. It also inhibits amino acid and fatty acid conversion to glucose. So again, the presence of this hormone in the blood in sufficient levels is actually going to tell the body that we've already got enough energy available to the cells to perform the function that they need to perform.